Today we are learning our last section of chapter 5, which is about trapezoids. A trapezoid, by definition, has one pair of parallel sides. So a parallelogram has both sets of opposite sides parallel. A trapezoid has just one set of opposite sides parallel. So we can have lots of different looking trapezoids because of that. Kind of our classic picture of a trapezoid looks something like this. But they can be standing straight up and down. You can have right angles inside of trapezoids. Okay. They can be on their side, so you could have the parallel sides could be the left and right instead of the top and the bottom. But the key is that in any of these we should have one set of sides that is parallel and one set of sides that is not. The parallel sides are called the bases, and the non-parallel sides are called the legs. An isosceles trapezoid is like an isosceles triangle, and it has two sides that are the same. So this kind of classic picture of a trapezoid is actually an isosceles trapezoid. The two sides that are the same must be the legs. It is impossible for the bases to be the sides that are the same because then it would actually be a parallelogram. Right? Because if one set of sides is parallel and congruent, that's a parallelogram. So the two sides that are the same have to be the legs. Theorem 518 says the base angles of an isosceles trapezoid are congruent. There are actually two sets of base angles. There's a set of angles along one of the bases and a set of angles along the other base. So the two bottom base angles are congruent and the two top base angles are congruent to each other. They are not all four congruent to each other, but there are two sets of congruent angles. The set of angles along one base are congruent, and the set of angles along the other base are congruent. Only in an isosceles trapezoid. That is not true in general.
Okay.
What is true about angles on the same side of a trapezoid? They will add up to 180 because the top and bottom, in this case, the bases are parallel, so we have some same side interior angles. That's true over here as well. Along one line, those should be 180, which means that one really has to be 90. These should also be 180. And this one would be these two angles should add up to 180 because you have to pay attention to where your bases are. Okay? And then likewise, the bottom ones would add up to 180 there. Okay? And that's because same side interior angles are supplementary. A couple more, another term and another theorem, but any questions on these ones so far? Our other term is a median. A median is the segment that joins the midpoint of the legs. So, that's not what I want to see. I'm having trouble making this the way I want it to look. There we go. All right, so I've got my parallel sides. The median would take the midpoint of those legs and connect them. And theorem 519 tells us two things about the median. It tells us that it will be parallel to the bases as well. And its length is the average of the base lengths. What does average mean? The mean? That's another word for it. How do I find it?
Add them both together and divide by 2.
Add them together and divide by 2. So if I said the top is 3 and the bottom is 6, we'll do 7. To find the average of that, to get the middle, I would do 3 plus 7 divided by 2. Just 10 divided by 2, or this middle one would have a length of 5. Okay? To find an average, you add up the two values and divide by 2. Okay? And the median will be the average of the two bases. Questions on that? We will do several more examples working with medians because that is what the majority of your homework is. But before we do that, let's take out that flow chart and fill in the left-hand side there about trapezoids. So at the top it said quadrilateral, and then over here we had parallelograms, and then all of our special parallelograms. And we filled all that stuff in yesterday over on the right-hand side about parallelograms, rhombus, rectangles, and squares, our special parallelograms. On the other side it says trapezoid. So this is where we want to fill out some information today. For trapezoid, we have 3 bullets, and one of them has an A and a B. The first thing, just like on the other side, we want to make sure we start with our definition. Put a star by it, highlight it, circle it, do something so you know this is a definition because definitions are really important. On the test, if I ask you to define a term, you should say only what is true by definition and not anything else that may be true about it. But that's just by theorems. We want to just say what does the definition tell us. So what does the definition tell us about a trapezoid?
With that thing, with exactly one pair of parallel. Yeah, I can't read it right now.
One pair of parallel sides. The second thing I want to say about a trapezoid is something that we looked at there in the notes, and that is that same side interior angles will be supplementary. And the third one there, where we're going to break this down actually to have an A and a B and to say 2 things about it, or we want to say 2 things about our median. What are 2 things that we can say about our median? Yeah.
Parallel to the bases.
Parallel to the bases. And I also heard the other one, the average of the bases. Then, underneath that, our chart flows on down to an isosceles trapezoid.
That's the one that like everybody thinks of.
Yeah, that's the kind of classic picture that people think of when they first think of a trapezoid usually. First thing we want to start with is definition.
Congruent sides, or congruent legs.
Congruent legs. An isosceles trapezoid has the legs congruent. The bases are the parallel sides, the legs are the other one. So the legs are congruent in an isosceles trapezoid. Then we had a theorem about isosceles trapezoids that told us something else about it, and what was that?
Base angles of an isosceles trapezoid are congruent.
The base angles will be congruent. Just like in an isosceles triangle, we had our isosceles triangle theorem that told us we would get some congruent angles. In an isosceles trapezoid, we will get some congruent angles. And our third blank here is like our bottom blanks on the other side, where if it's flowing down for something, all trapezoid rules apply here as well. So anything that's true about a trapezoid is true about an isosceles trapezoid, because an isosceles trapezoid is just a special case. Just like yesterday, we said everything that's true for a rhombus has to be true for a square, because a square is just a special kind of a rhombus.
Did we do square yet?
We did do square yesterday,
No, we
yes.
didn't.
No, we didn't.
We didn't do it.
Yeah,
We didn't do square yesterday?
No.
That's bizarre. Let's go do that.
What does number 2 say?
I think it's bunk.
Base angles are congruent.
Base angles congruent. Alright, so yesterday apparently we missed out on square. So first thing we want to do for square is the definition. What's the definition of a square?
Congruent.
4 congruent sides and 4 right angles. There's the definitions of both a rectangle and a rhombus. which is what this is actually flowing from. So the other two blanks for square should then be that since this is flowing down from rectangle and rhombus, all rectangle rules apply and all rhombus rules apply. So that's why yesterday in that chart for your homework, square was checked so much. Because if it applies to a parallelogram, it applies to a square. If it applies to a rhombus, it applies to a square. If it applies to a rectangle, it applies to a square. So a square has a lot of special characteristics about it because anything that's true for any of the others gets to be true for a square as well.
What does letter B under trapezoid say?
Average of bases. All right, so let's do some examples now with trapezoids and finding medians. In this first one, we want to solve for x. X is the median. We can tell because we've got the little segments that are marked as being the same, so we know it's connecting the midpoints. To find a median, we are told by theorem that it is the average of the bases. So we take the two bases and add them together and divide by 2. And I get 22 divided by 2, which is 11.
Is that all we're doing right now?
For the middle one, we want to find x again as the median here. To find a median, we add together the bases. What are the bases here?
5 and 10.
5 and 10. The bases are not always the top and the bottom. The bases are the parallel sides. Okay? So the bases are not in this problem the top and the bottom. The bases are the parallel sides, the 5 and the 10. Add those up, divide by 2. We get 15 over 2, or 7.5.
How did you choose 10 and 5 bases?
Because those are the parallel sides. The parallel sides are the bases. In the next one, we're looking for the length of this median. We're not trying to solve for x. We actually want to find what is this median length. We want to find what is that length in the middle. To find the length of a median, we take the top, or the bases, and the bottom, and add them together, and divide by 2. And that should be equal to our median.
Oh, so that's
What happens in the top of that fraction?
X's go away.
X's go away, and I get 22 over 2, which is 11. So our median in this problem is 11. And this problem illustrates something important about a median. It's the average of them, but we can look at the difference that's being done to each base, and that should be the same. So 11 minus x is the same distance away from 11 as 11 plus x. Okay? Or looking at the first one that I did in purple, how far are 6 and 11 apart?
10.
6 and 11?
5.
5. And 11 and 16?
5.
5 apart. Okay? So your median should have the same distance away from one base as it does from the other base. In the middle one, how far are 5 and 7.5 apart?
2.5.
2.5 and 7.5 and 10?
2.5.
2.5 apart. Okay? So 11 minus x and 11 plus x are both the same distance away from 11. Okay? That can help us do a shortcut in the next problem. In the next problem, how far are 12 and 21 apart from each other?
9.
9. So the other base should be 9 away from 21 as well, which would make it be
30.
30. Okay? I'm still going to show how to do the algebra on solving this because it's important that you understand the algebra because in some problems this shortcut won't do it for you. And we actually have one like that here as well. So what I would do here algebraically is say that 12 plus x divided by 2 should equal 21. Same thing as we were doing in the other problems. Add together the bases and divide by 2 should be equal to the middle. It's just in this case we know the middle and we don't know one of the bases. How do I undo an algebra dividing by 2? Multiply by 2. So I'm going to multiply both sides of this equation by 2, which will undo the dividing by 2, and leave me with 12 plus x equals 42.
Minus 12.
Subtract the 12, and x equals 30, just like we expected. Okay. And the next one over, how far are 34 and 29 apart from each other? 5. So the other base should be 5 apart as well, which would put it at 24. Okay? So it is appropriate to use that shortcut when possible. I don't mind at all. Okay? It's true. It's not just like lucky guessing. That's true math. Okay? That it should be the same distance away. So it's fine to use that when you can. In this bottom problem, you can't. Okay? Because we don't know what either one of the bases are, so we don't know how far 8 is away from 2x minus 1 or how far away it is from 2x plus 1. So we can't use that shortcut here to solve for x. So we need to do the algebra. And what we want to do is take our bases and add them together, divide by 2, and it should equal the middle. Yes?
What if all parts you have to solve for x? Like the midpoint, you have to solve for x as well as the each of the bases.
What was that?
All parts of it you have to solve for x.
Oh, in the green one, we didn't want to solve for x, but otherwise all the other ones we were going for.
No, I mean,
with
like-
x is fine.
Every part, like the midpoint, you have to solve for x also.
What's a what if?
Like, what would the algebra look like for that?
For which one?
Not for any of those.
Oh.
Like if you had to solve for x for each of the bases plus the midpoint.
Oh, it looked the same thing. You just have more x's in your problem.
Okay.
So like if this was like 8x, you mean, instead of just an 8, if it was like 8x, yep, so then you would just have more x's in your problem.
Okay.
Yep. Same process every time still though. Add together the bases and divide by 2 equals the middle. Alright, so how do I get rid of dividing by 2?
Times by 2.
Multiply by 2. So that cancels that 2 on the bottom. I can combine up some like terms here. I got a 2x and a 2x, which gives me a 4x. A minus 1 and a plus 1. Cancel each other out. And 8 times 2 is 16. So x equals 4. Okay? Yep, and if in that problem it was an 8x, then you would just end up, having more x's in the problem. Okay, so it's okay for all 3 parts to have x's on them. You still just set it up and solve it the same way. All right. Your assignment tonight is from 5.5, except not 21 to 25.
Is our notes right?
No.
So cross.
So cross out 21 to 25. They're not proofs, but I just still decided not on those problems. There are no proofs tonight.
Thank you.